In this video, we're going to be using the patient satisfaction data. So if you haven't already, go ahead and do the Socratic questions to practice using R and to also select a model for this data. So we're going to be using age and anxiety to predict satisfaction. And let's say we're interested in saying which of those explanatory variables, age or anxiety, has the largest impact on patient satisfaction. We could use the slopes, but remember that units are important when we're talking about slopes. And so it's hard to compare a 1-year increase in age to a 1-point increase in anxiety since they're on completely different scales. So one thing that we might want to do is to standardize the variable by subtracting the mean and dividing by the standard deviation. So you can see the formulas there. And if we wanted to do this in R, we could just use the mutate function. So we're defining new variables, standardized age and standardized anxiety. And you can see the formulas here. It's just a little bit messy because of the parentheses. And then I just assigned this back to the same data set name, patient satisfaction 2. So I'm just writing over that name. So let's take a look at the new patient satisfaction 2 data set. It has satisfaction, age, severity, anxiety. Those were our original variables. And now we have a standardized variable, age, and a standardized anxiety. So thinking about what these numbers mean, I'm just going to pick one. Let's just pick this one down here at the bottom. So this is in the row for patient 6. And this is a negative number. So what this is telling us is that for patient 6, patient 6's anxiety level is below the mean, right? It's a negative number, so it's below the mean. And we're not just looking at the distance below the mean, we're looking at how many standard deviations below the mean. So patient 6's anxiety level is 0.29 standard deviations below the mean. So if you remember from your intro class, a z-score, that's essentially what this is. We have the z-score for each of these variables. And then you plug them into your model just like you would any other variable. So we're going to fit a linear model, but instead of using regular age and anxiety, we're going to use the new standardized versions of these variables. Okay, so take a second here, pause the video and see if you can interpret the intercept, interpret the slope for age, and also just take a look at the output for the standardized variable versus the unstandardized variables and see what you notice. It may be easier to look at the whole page, so I'll go ahead and do it this way. Okay, so pause the video and see if you can answer each of these questions. So in general, the intercept is going to be the predicted value of y when all of your explanatory variables are equal to 0. So what does it mean for the explanatory variables to be equal to 0 when we're using standardized variables? So 0 would mean that that patient is 0 standard deviations from the mean, or in other words, they're right at the mean. 61.565, this is the predicted satisfaction score for a patient with average age. Right, they've got a 0 for their standardized age and average anxiety. So this is another reason that people sometimes like to use standardized variables, is that instead of having an intercept that a lot of times isn't meaningful because 0 isn't a reasonable value, the intercept is going to be interpreted as the predicted value of the average person, right? The average of all of these variables. Okay, and then for the slope, it's usually going to be the predicted change in y for a 1-unit change in x, right? But here, the standardized variable increasing by 1 really means by 1 standard deviation. So when we look at this negative 10.706, that means satisfaction scores are predicted to decrease by that amount as age increases by 1 standard deviation. And again, this allows us to compare things even when they're not on the same scale. So let's just compare the output. So this is the one using standardized variables up here at the top, and then we have the unstandardized variables down here. So you can see that we're getting different slopes and intercepts. That's not surprising because those have different interpretations, so they're going to be different. We do have the same p-values here. That's not always the case. If you have a model with interaction, for example, the p-values can change, but you are going to have the same fit statistics. So I'm going to go ahead and write that down. that we have the same amount of variability explained.